Good afternoon, my algebros. So as promised, I make these little solution videos. So we're going to go through our first one, which is our skills pack that we were doing before. Okay. So on the first page, it reminds us how to add and subtract fractions. And you do the same process for both of these. You have to first get a common denominator, and then you either add or subtract the numerator, which is the top. So let's take a look at this first sample. It was already given to you, and then all you had to do is add the top and simplify, right? And we mean simplified either gets to a whole number or it can reduce to the simplest form. But we do not need to make a fraction become uh, a mixed number, right? We're okay. There's nothing improper about those fractions. They just happen to be a little top heavy, right? So go ahead and check your solutions for this. Most of these we did in class already. And so with these videos, what you can always do, usually when the topic is the same, I just kind of let you look at what I did. And then when there's more steps to things, I will go step by step, right? You can always pause the video and really check your work. That's really helpful. So all of these had a common denominator, so all we had to do was to add the top and to simplify if necessary. So like on this one, when we added the top, and notice that we moved the negative up here and the negative up here because we always want to be adding things. We get rid of that whole idea of subtracting. When we combine like terms, we are always adding them. They just might be a negative, right? So -5 and -1 is -6, and 9 stays the same. And then -6/9 can reduce by dividing by 3. They both have a factor of 3 to get to negative 2/3, right? Okay, same here with this one. We know they're both even numbers, so we could cut it in half. Right, then that brings us to these kinds of problems which do not have a common denominator. So we look, sometimes the smaller can become the bigger, but rarely do we have the bigger become the smaller. But for the most part, it's either the same as this or they have something in common. On this one, because 2 can just multiply by 2 to become 4, we multiply the bottom by 2, getting 4. But whatever we do the bottom, we do the top, which is why it's 2/4 now. And then we combine our terms, getting 7/4, and that's not reducible, so we leave it alone. Here's the next one, and the following one. So all of these are similar kinds of problems because one could multiply to become the other, right? On this layer, we see that 3 cannot become 5, so but we can multiply 3 times 5 in these scenarios. That's how we get 15. So this side is multiplied by 5, and this side is multiplied by 3, and then we add our top numbers, our numerators, and we get 7/15. On 6 and 4 as our denominators, the common or the lowest common denominator would be 12. That's why we multiply this side by 2 and this side by 3, then combine the top numbers, getting our fraction, and then we can simplify this one. In here with this. Right. Let's look at this layer right here. Um, 8 and 5, we try to figure out what they could both become, and it turns out that 40 is the lowest one. So we multiply this side by 5 and this side by 8. We combine our terms, and that is our solution. Same with this one. Same here. Okay. All right, move on to multiplying and dividing fractions. This is so much easier than adding and subtracting. You don't have to get a common denominator. It's quite simple. Every single time you're multiplying fractions, all you do is multiply straight across. 5 times 1 is 5. 2 times 2 is 4, and simplify it if you can. This does not need to be simplified. So we just multiply straight across, very straightforward, right? The only thing that makes it tricky is if we have negatives with positives. So if I have 2, we have to remember the relationship rule when we're multiplying, and that means that a positive with a positive makes a positive, right? We talked about this in class, that they both think positively, so it's a very common relationship. And then a negative person with a negative person also agrees, right? That everything is uh, the same, so it's positive. But when they're opposite, when you have a positive person and a negative person, there tends to be a little conflict all the time, which is why we call it negative. And of course, this is just a sample to help you remember. It's not actually how relationships work. Okay, so now we have this negative out here. We're going to go ahead and move that to the top, and then we multiply straight across and reduce if we can. Same with this one and here. This was a bad sample in class. We went over it in class, so I'll move on to the next one. When I'm multiplying a whole number to a fraction, I just can make it a fraction, and we multiply straight across, getting -6/3, which reduces to a whole number of -2. Here we go with this one, no reducing necessary. All right, then we go down to dividing fractions. When I divide fractions, I'm actually going to go ahead and multiply again. Just like when I'm adding or combining like terms, I'm always adding. I just happen to be adding negative numbers, but I always change it to an addition situation. Here, we always change it to a multiplication situation. So we have this little way to remember it. Keep, change, flip. You keep the first fraction the same. You change the division sign to multiplication and you flip the second. The technical term is called reciprocal, or I like to say reflippical, reminding us that we flip it upside down. And then again, we just multiply straight across and simplify if necessary. And here's all of these for you to check. And here. And of course, you can go back, pause the video, zoom into the video as you need. The next review page was PEMDAS, orders of operations, really important. And we talked about what happens if you do this out of order versus if you do it in order. Sometimes you get the wrong answer, and sometimes it just takes too long. So on number 1, we talked about if I were to just do this left to right, then my answer would be wrong because if I added this first, I'd get -1, and then this is 6, and 6 minus 1 would be 5. I'm sorry. If I added went across here, and went -1 and then added that to 2, I'd get 1, and 1 times 3 is 3, and that's not 5, right? So we have to take care of these things first. This is 6, subtract here, then combine them and get 5. Number 2 is a really good example of this isn't going to be wrong if you do it a long way, but it just takes you so much more steps. So this half, the red half, is doing it the long way, using the distributive property here, give me 35 and -5. Then I'd have this fraction over here. I'd be like, oh no, do I have to get a common denominator? You don't. You go ahead and divide that, you get 4. And then you add these, start adding these together, and you would finally get 38 as your answer. But if we follow PEMDAS, we would do the parentheses first, which would give us 6. And 6 times 5 is 30. And then we have plus 4, and 8 divided by 4 is 4, and you quickly get to 38 without all that work. You can go ahead and check all these. I'll just leave this screen like this for a little bit. I tried to highlight to show you what you should be doing first. And if you have any questions on these, I'm happy to go over them with you either in class or during my office hours, which are I'm open for warrior time. I do tutoring in the classroom on Monday and Thursday, and then my lunch office hours are Monday, Tuesday, Thursday. Wednesdays, I actually have meetings, so I have to kind of change that for you guys a little bit. All right, let's move on to evaluating expressions. Here we substitute, right? I always hear this term of plugging it in, and that's fine. It's not unwrong. It's just not the same term as substitution, and we use this idea of substitution so often in Algebra 1, Algebra 2, calculus, um, all of it. Like you end up doing U substitution. Anyway, you get used to the term substitution. It's nice. So let's use the right vocab and we'll say we're substituting. So it tells us what these variables represent in these scenarios, and we substitute that value in. When we substitute in, it substitutes for the whole value. So this is 2 times A, and A is 2, so it's 4. And this is 3 times -5, so it's -15. Then we combine our like terms with PEMDAS and we get -11. And number 2, we talked about this a lot. If I am substituting a negative number in here, B happens to be -3. The whole -3 gets substituted for 2, for to, I'm sorry, to be squared. So it's technically -3 times -3, why it's +9. Because when you substitute in a negative number into something that is squared or square rooted, the negative goes with it and is attached to it. It's not on the outside, which is different because e squared is 6, and 6 is just a regular 6, so you square this first, and the negative's on the outside, which is why we subtracted 36 and get -27. Okay, go ahead and check your work here and here. And PEMDAS is one of those things that it seems so easy to not make a mistake, and yet we sometimes do, and it causes just a big mess. So we really want to make sure we're very competent with this skill. All right. Combining like terms, we did the Skittles lab for this. You can't, when you're adding and subtracting things, you're always combining like terms. So we always add them up. We just happen to be adding negative numbers, and you can only add things together that are the same. So you can see on the first one, we have an x plus an x plus 3 more gives us 5. And then we have y. And we write this in the orders of alphabetical order first, and then 1, 2, 3, like ABCs, 1, 2, 3s. So that's why x comes before y. Again, x comes before y. And yz comes before -1 because do all the letters first and then the numbers. Go ahead and check your work. So parents, if you're watching this video, keep in mind that students get a perfect score in all homework that they turned in on time, and they tried every problem. It's a safe place to fail. So if they fail, like let's say they did everything wrong, that's their job to go check the video later and make sure they've learned from it. And if they can't understand from the video corrections, then they need to be seeing me during office hours, either at lunch, Monday, Tuesday, Thursday, or at Warrior Time, Monday, Wednesday in E229, our classroom. All right, let's talk about some basic exponent rules. The difference here is between adding and multiplying. And when you multiply, if I have x plus x, we know because we just did this combining like terms, that would be 2x. But x times x, the rule is you add the exponents. So that's why it's 2 up here, because 1 plus 1 is squared. And we talked about, like, if this doesn't make sense, then go ahead and substitute a number. So if I put in like 3 for this, I'd have 3 plus 3, which is 6. And that is 2 times 3. So we know, yes, that works here. And on this side, if I do 3 times 3, that's 9. And 3 squared is 9. So again, we know this concept is correct. So we add up our exponents. If there's no exponent there, there's at least 1. So we have all these are 1, and these are 1. And why we do x's first, because it's alphabetical, then y is second. And then when you have bigger numbers, you just add those bigger numbers. So 2 plus 3 is 5, and so forth, until we get to a power of a power. When we have a power of a power, it's x to the fourth power 3 times. So we know there's 3 layers of this, and if we count all these up, we get 12. But the shortcut is we just get to multiply. 3 times 4 is 12. They have to have the same base. That's the only way it works for all these, by the way. Same base. So here we go. Go ahead and check your work on here. And let me just remind you too, if I had like 2 to the second power times 3 to the second power, this would not be 6 to the fourth. That's a big no-no, right? That's not going to work out because technically 2 to the second would be 4 and 3 to the second would be 9, and that would be 36. But 6 to the fourth power is not 36. It's 6 times 6 times 6 times 6, which would be 36 times 36. And you know you're getting a pretty big number there. So you know this whole thing does not work out, right? So you can't do it. It has to have the same bases or a must, right? It must have. Okay, this little add thing. All right, so then we slide down here when we're dividing. If we multiply and we get to add, we divide, we get to subtract. So I can use the subtraction rule here. Let me just kind of clean this up for you because we talked about this in class. So I still have the notes on here. All right, so if I look at this from a logical standpoint, I have 5x's and I have 2 on the bottom, and these would cancel this one out, cancel this one out, and I have 3 left over on the top, right? So I'd have x to the third. Or I could have said that 5 minus 2 is 3, and that's how you would get that. The one confusing thing about this is if you just use the subtraction rule, how do you do with negative exponents if there was a bigger number on the bottom? And that's because we haven't talked about negative exponents, and we'll get to that in chapter 6 later. So I like to see it as the who wins rule. What does that mean? Let's say I flip this upside. Let's say I have x to the sixth and x to the eighth, right? I would play who wins. Who wins between 6 and 8? Well, 8 wins by 2, and I'd leave it like that. Okay, little sample there. We subtracted on this, which brings us to our last review page. You can see why we took a week to do all this, about our coordinate plane. And coordinate planes are, and I went over this really detailed in class, are a number line on the x-axis and then it that goes left to right, and we have this point of origin in the middle, right? Let me switch to the pointer, it's better. So that's always 0, 0. This is always our starting point. And we have the x-axis, positive, negative, and 0. And then with the y-axis, I usually do this green to remind you that it's the ground level, right? And you have to start on the ground before you can jump up. So you always start moving the x value first. And then the Y is to the sky and to the sea below. So it's horizontal. So it's just taking a number line and moving it. So it's up and down, still 0 in the middle. And then quadrants, this is our first quadrant, second, third, and fourth. We talked about that more in class, why that is. And then we have every point is an X and a Y. It's always alphabetical. So for letter A, we would start at 0, 0. We'd go over 3 and up 4. And we would label it with the letter A and put that it's in the first quadrant. Anything that's actually on an axis, like letter C, we see is right here because there wasn't any X. It was 0, so we would just go down for that. We would just say this is on the Y axis, or it's called a Y-intercept. On F, it's an x-intercept, which is why we say it's on the x-axis. So go ahead and check all your points there. And this is your first review video that you can go back to at any time to be like, wait a minute, we did graphing. What did I forget? Or one of those simple things. All right. Have a great day. I'll talk to you later. This one's pretty long for our first one. Most of them will be shorter, but we did these for an entire week. Okay. Take care. See you soon.